just for the record, I left the little witch connected up to this tomato overnight, and it's now 6 o'clock in the afternoon or early evening, and she's still just twitching that little bit. So there's clearly not enough to get her going properly, but it hasn't run out. It's stayed about the same amount. She was doing that little twitch before. So that's about 24 hours now. Well, no, I exaggerate. About 18 hours. Because it was midnight-ish when I stuck her on the tomato and left her. So she's been doing that. Just that little twitch for about 18 hours on one little tomato. And a zinc nail and copper wire. So copper anode, zinc cathode. Hi guys, finally going to get round to using a potato. What I've got here is a pill box, or commonly called a Dosset box, I believe, which used to be my wife's mother's. She passed away quite a while ago, but we've got quite a few of these empty boxes. It's for people who have to take lots of pills on a regular basis. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Morning, midday, evening, bedtime. So there's 28 cells there. What I've got here is a bit of garden wire, galvanised wire, which I believe means it's zinc plated. And some copper wire, and another bit of zinc wire, and I'm going to bend up another bit of copper wire in a minute. So they're arranged so I can cut up the potato into little cubes, fill the cells up, and then we'll join seven of them in parallel. So that'll be 7 cells, and then another 7 cells, and potentially another and another, so we could have 28 cells altogether. But we'll have, say, 7 in parallel, and then we'll link them to the next 7. So 7 parallel, and 2 banks in series. So whatever voltage we get from there, which I think is about, from memory, somewhere between half a volt and 0.7 a volt or something like that. So if we have 2 in series, we should get over 1 volt with a reasonable amount of capacity. I mean, they're only going to be small cubes in there, but that's what I'll do. I'll just show you the beginning of bending this up. So I just bend a bit like that, then I measure so I get the same gap, and then bend that straight back the other way, crimp it together, and then the next one along, check my measurement, down there. I think you get the general idea. So we should have zinc anode, I think it is. No, sorry, other way round. Copper anode and zinc cathode, I think. I can't remember. Right, I'll do that all the way along, so I've got 2 banks, and then if we find we need more, I'll double it up. Right, there we are. That's our rail of copper, rail of zinc, rail of copper, rail of zinc. So, according to me, if we go on there and there, whoa, 9.37, or sorry, 0.937, 0.936, and on that one, 0.87. So close to a volt on each one of them. Let's just try, oh, I've buried it. Move that out of the way. Bring this one over. Are we on or off? That should be off. So black on there, red on there. Oh wow. There we go. We are running on a potato battery. Let's see if we can measure that voltage while it's drawing current. And it's still about 0.8 of a volt. In that case, we don't need a second cell. We can probably have a little witch. Take her off her tomato that she's been on all day. She's rocking around a little bit there. Those are a bit springy. Let's reposition that. Yeah, she's going too. In fact, she's very happy. So that's really where I was aiming to be quite a while ago. That one's slowing down a bit, I think. I don't know, still going. Let's just move the camera down a bit. Yes, it looks like the solar witch draws or needs less current to get her going compared to him. What we could do is join them together, see what happens. So copper to copper. Zinc to zinc. It's a bit more positive now. Yeah, I'll take that one as a success. So a simple potato battery. We've got 7 cells in parallel with copper for the positive and zinc plated wire, galvanized wire for the negative. And then another 7 cells, and we could run both of these individually, or I've put them in parallel. So we've doubled the capacity again, or I could rewire them so they're in series, but at the moment we're positive to positive, negative to negative, so we've got all of that lot is in parallel. And if we go across here, yeah, 0.8 of a volt. Thereabouts. Oh, sorry, moved the camera, didn't I? Can we see that now? Yes, we can see that now. 0.8 of a volt from potatoes. I'm surprised that this one needs more current to get going than that one. I thought it would have been the other way round. No particular reason, I just thought they would be the other way round. I guess the next thing to do is to leave one of these running and see how long it runs for. And logically it ought to be her, shouldn't it? Because this one's not very impressive at all. I'll think about that. That'll do for today anyway. So, a genuine potato battery. Battery being multiple cells. Thanks for watching. If you like that, then you might like this. And if you like this and that, you might like to subscribe over there.